So the moment I uploaded that last video, I was like, oh shoot, I should talk about how in the identity function, just like in the first problem, in the identity function we can see the two transformations being one and the same. I was like, oh, I have to add that in an extra video. So before I get to number 3, I have to talk a little bit more about this amazing fact of what the identity function can show us. So you already saw, and I showed this to you in class, and I yelled at you and everything, that here we've got this amazing result that this identity function, the blue function, just x, when we transform it plus 5, that can be thought of equally well in two separate ways. We see this orange transformation occurring of movement up 5, as if the y values are all moving up 5. And then we also, at the same time, and I've made this one green, we can see this green transformation of left 5. So I already talked about that once, but I really like it with the visualized sliders and the points moving and it's doing it automatically. It's pretty nice. But anyway, the same thing happens over here with 2x, right? It's this really powerful moment where we can see that the 2x might have become one of two transformations. Over here we can see the y values. I'm starting at the point, right, here's my reference point, 1, 1, which is a point on the graph of just x, h of x equals x here. And then we're seeing how as I change x into 2x, visually, I turn it into the red function. With the identity function, we could think about it equally well in two separate ways. We could think about it as the x value becoming a new x value that is half as large, right? That's what's happening with this green point. One x value, the y could not change, and the x coordinate could become something half as large. That's what happened when we did g of f of x. All the x coordinates became half as large. But we could also equally well, right, with this one function, the identity function is the only one where we can see both transformations in one. With the identity function, equally well, we could talk about the y value dilating to a value that is twice as large. We can see these at the same time with the identity function. Now, as soon as we move away from the identity function, the two possibilities of 2x are going to become separate. Either it's a y transformation or it's an x transformation. For any other function besides the identity function, we're only going to see one of those two possibilities expressed. But the nice thing I thought about these problems was we could see really clearly how the 2x had within it two different potentialities. Either to become or to be thought of as a transformation of the y values by a factor twice as much, or equally reasonably to be thought of as a dilation of the x values to by a factor half as much. Either one of those is a good way to think about it when we're transforming the identity function. So anyway, I just thought that was a nice illustration. Now you can move on to problem 3.